Ever wondered how an AC works? Today we delve into the fascinating world of air conditioning. Contrary to common belief, air conditioners are more than just cooling machines. They play a pivotal role in maintaining the air quality within a room, offering us a comfortable and healthy environment. From hot summer days to humid monsoon afternoons, air conditioners are our trusty companions. Now you might ask, how do they achieve this? In the next few minutes, you will understand the simple science behind these machines. At the heart of every air conditioner is a basic principle called the refrigeration cycle. Now let's break this down in the simplest terms possible. Imagine a busy day, the sun is blazing, and you're feeling the heat. What you're feeling is an abundance of heat energy. And what does an air conditioner do? It takes this heat energy and says, "No thank you, you belong outside." Think of the refrigeration cycle as a heat thief. It sneaks into your room, steals away the heat, and then discards it outside. This cycle consists of 4 main steps: evaporation, compression, condensation, and expansion. During evaporation, the AC uses a coolant or refrigerant that absorbs the heat from your room. It's like a sponge soaking up water, but instead of water, it's heat. This heat-laden refrigerant then travels to the compressor. The compressor, a big, strong component of the AC, squeezes the refrigerant, making it hot and high pressure. Now, this might seem counterintuitive. Why make something hot when we're trying to cool down, right? But bear with me. This hot refrigerant then goes to the condenser. Here, it loses its heat to the outside air and turns back into a cool liquid. Finally, the expansion valve releases this cool refrigerant back into the room, and the cycle repeats. And that's how the refrigeration cycle works. But let's dive deeper to understand the components that make this possible. An air conditioner is made up of several key components. The heart of any air conditioning system is the compressor. This powerful machine is responsible for compressing the refrigerant gas, which increases its temperature and pressure. Think of it as the engine that drives the entire cooling process. Next, we have the condenser. This is where the hot, high-pressure refrigerant gas travels to after leaving the compressor. The condenser's job is to dissipate the heat carried by the refrigerant. As the gas cools, it transforms back into a liquid state, ready for the next phase of the cooling process. Now let's talk about the evaporator. This is a heat exchanger coil that's responsible for transforming the liquid refrigerant back into a gas. As this transformation happens, the evaporator absorbs heat from the surrounding air. This is the key moment when the air around you starts to feel cooler. There are other components too, like the expansion valve, which regulates the flow of refrigerant into the evaporator, and the air handler that circulates cooled air throughout your room. But at its core, the compressor, condenser, and evaporator are the 3 main components that make the magic of air conditioning possible. Each part has a unique role in the cooling process, and when they all work together, they create the perfect environment for you to relax in. These components work together in harmony to keep your room cool and comfortable. So, to put it all together, we began our journey of understanding air conditioning by introducing the very concept of it, a system that not only cools, but also dehumidifies and circulates air. This is more than just pushing a button and enjoying a cool breeze on a hot day. Then we dive deep into the foundation of how an air conditioner works, the refrigeration cycle, a process that seems like magic, but in reality, it's a brilliant application of physics. In simple terms, the refrigeration cycle is about capturing and releasing heat, making the air inside your room cooler. Next, we explored the main components of an air conditioner and their roles. The compressor, the heart of the system, compresses the refrigerant, turning it into a high-pressure gas. The condenser then cools this gas down and condenses it into a liquid. The expansion valve, a crucial player, reduces the pressure of this liquid refrigerant, turning it into a low-pressure gas. And finally, the evaporator absorbs heat from your room's air and uses it to evaporate the low-pressure gas back into a high-pressure gas. In essence, your air conditioner is a continuous cycle of compression, condensation, expansion, and evaporation, each component playing its part in this symphony of cooling. Next time you turn on your air conditioner, you'll know exactly what's happening behind the scenes to keep you cool.